So these three problems, in order to solve them, they all use the skills that you already have, but they all add in one new twist. And that new twist is that they're not equal to 0. Because in all the previous problems that we worked with, they were always set equal to 0. Well, one of the beautiful things about math is that if you look at something and you're not sure what to do with it because of the form it's in, you can usually figure it out by just putting it into the form that you know. And so with actually each of these, your first strategy then should be to set the equation equal to 0. In the case of number 1, which side do you want to be 0? Well, I like to try to keep my x squared term positive just as a general rule. It usually makes my life a little bit easier. So I'm actually going to try to move each of the terms from the left to the right. So I'm going to be moving each of those over. So for instance, how do I move this 4x squared over? Subtract 4x squared from both sides. And then you could do the same thing with the 6x and with the 11, and then once it's equal to 0, then you can solve it from there. So this is what we're looking at when we set it equal to 0. Now that we have it to this point, we have to then go through and see what method to use. Can I use the square root principle on this? In other words, can I manipulate this so I can just take the square root of both sides? The answer there? No. How do I know? Because x is appearing twice here. Because the x appears twice, that means I can't just take the square root of both sides. Okay, so that leaves me with two options, factoring and quadratic formula. Okay, so the next one I check is factoring. And I look at it and say, okay, is it factorable? Is it factorable? Yes, it is. So factor it in order to solve it. It's going to be a lot easier than the last resort, which is quadratic formula. All right, and then when you factor it, what two numbers add to 3 multiplied to negative 10? It's 5 and negative 2. And then remember, basically now, in order to solve it, we're saying what plus 5 equals 0 and what minus 2 equals 0, which hopefully you can just do off the top of your head now. But if not, remember how we get it. We're basically doing x plus 5 equals 0 and solving that. So subtract 5 from both sides, x equals negative 5. And the same thing with the x minus 2, what makes it equal 0. And so in that case, we're adding 2 to both sides, so x equals 2. There's our final answers for that first one. Repeat the process for the second and third as well. Set it equal to 0, then choose your method and go from there. All right, once we set it equal to 0, we look to see which method. Notice again, we cannot use the square root principle here. I cannot take the square root of both sides because the x appears twice. So then the next question is whether it's factorable or not. I'm going to give you a hint on this one in case you're feeling a little stuck. Yes, this one is factorable. But it's not as simple as what just adds to negative 12 and multiplies to 7. Because it's not an x squared, it's a 5x squared. So because of that, that tells us that we have to do a little bit of guess and check, which usually we do by the box method as a way to visualize it. Of course, remember, you don't have to use the box, it's just a way to visualize what's happening in it. But we're looking to complete the box that would give us that result, where the diagonals add to negative 12x. Now, as you're doing that guess and check, to get the 5x squared, the nice thing about it is the 5, there's only one way to get the 5. Really, it's got to be 5x and x. Also, to get the 7, there's really only one way to get the 7. It's 1 and 7. So really the question that you have is, will it be 1 and 7 like that? Or will it be 7 and 1 like that? And that's where you do the guess and check to see which one's going to work out best. All right, and as you're doing that guess and check, hopefully this is where you end up and you see this and it's looking pretty good. But notice those diagonals add to 12x and we want it to be a negative 12x. Whenever you just need to flip the sign of it, it tells you that we need to flip the sign of both of those two numbers there. Because notice the negative times the negative still gives us the positive, but now it adds to the negative 12 instead on the inside. And so once you have that, then you have your factored form, because you read across the top for your first factor, 5x minus 7, and you read across the side for your second factor, x minus 1. And now that you know that, you can go ahead and solve it. You can figure out what x is. Remember, you're setting each of those parentheses equal to 0. All right, and so when solving that, especially for the first parentheses, you'd probably do well to actually write it out as its own little equation. 5x minus 7 equals 0 to tell us what makes it equal 0. So you'd add 7 to both sides, and then you divide both sides by 5. So we should find that x equals 7/5. Or if you prefer the decimal, yes, you could also write that as 1.4. I'm going to go ahead and live in the land of 7/5 though, just because it makes it a little bit easier to see where that number came from. And of course, what's the other solution? X will also equal what? 1. Because what minus 1 equals 0. And that's our final answer there for number 2. Now for number 3, again, what's our first step going to be? Set it equal to 0. Because on all of these, you always need to start by setting it equal to 0, because all the rules, all the methods we have, basically start by setting it equal to 0 and then going from there. When we set this one equal to 0, we subtracted 10 from both sides. We end up with this equation. Now, we again need to look and see, can we use square root principle? No, because again, x appears twice. Can it be factored? Well, we actually would need to check and see if it's factorable, but thankfully 5 and 3, it's pretty easy to tell what combinations that could possibly give us. We could maybe get a 2 out of it, or we could even get like a 14 or a 16, something like that. But there's not a way we can get the negative 1, which is what we would be looking for in the middle. So it's actually not factorable. And if it's not factorable, we use the, quadratic formula. Now, as a refresher, quadratic formula, you might have checked your notes for it, but once you've got it down, this is what you should be seeing for your quadratic formula. So check this, make sure you have everything in there correctly on the first line, and then figure it out from there, and go ahead and get your answer as a decimal. I'm going to round to 2 decimal places. All right, when you do those calculations, make sure you can get the correct answers out of the quadratic formula. You should be getting answers of about 0.88 and a negative 0.68.